Okay, hello everyone. This is Mr. Life Changer again. And so this is a continuation, the last part of the series 30 questions on electric current and all that has to do with current. Number 21 here says a 1000 watt electric iron operates on a 250 volt main supply. The minimum fuse rating suitable for this appliance is, now fuse rating is actually shows us the minimum current, okay, the maximum current that it can allow to pass through it. Above that current, it is going to melt, and the fuse rating should either be equal to or a little greater than that maximum current. So in this case here, we are given power. Power is supposed to be IV, so your fuse rating I is P over V. Your power is 1000 watts, and the voltage is 250, so this is going to give us 4 volts. Okay, so sorry, 4 amperes. Now there is no 4 amperes in the option. If there was 4 amperes in the option, you take 4 amperes. Now, but remember, it is even safer in practice. It is safer to make it a little higher than this 4 amperes, okay, so that your instrument is going to be safe. So the best answer here is C, something a little higher than the 4 amperes. I hope that makes sense. Okay, so that leads us to the next one. It says that number 22, a current of 3 amperes flows through a 4 ohms resistor for 5 minutes. The heat energy dissipated in the resistor is, the formula for heat energy is, in this case, since we are giving current and giving resistance and giving time, it is I squared RT. That's the formula. That's the formula for heat generated in a wire when current passes through the wire. Okay, so the current here is 3, so this is 3 squared times your resistance is 4 times the time. 5 minutes means 5 times 60 seconds. Okay, so this is 300, this is 12, and this is 10,800. Okay, so number 23, according to Joule's law, the heat produced in a conductor is directly proportional to the square of the current, the resistance, and the time. That's the formula we use, I squared RT, proportional to the square of the current, the resistance, and the time. Is that easy? Okay, so that leads us to the next one, number 24. The electric power dissipated in a resistor carrying current I is correctly expressed as, the answer is I squared R. That's the formula for power. Now, power can be IV, power can be I squared R, power can also be V squared over R. Kindly note that these are different ways of solving for power or finding power, and they are all correct, okay, depending on what is given. If you are given current and voltage, you use IV. If you are given current and resistor, you use I squared R. If you are given voltage and resistance, you use V squared over R. I hope that makes sense. Okay, so the next question says that 3 resistors of 2 ohms, 4 ohms, and 6 ohms are connected in series, okay, across a 24 volt supply. The power dissipated in the 4 ohms resistor is a very important topic, a very important question. Now, if I put this in a diagram, the total voltage is 24 volts, and this is 2 ohms, this is 4 ohms, and this is 6 ohms. The best way to do this is to find the total resistance first off. The total resistance is going to be 2 plus 4 plus 6, okay? Because they are in series, which is equal to 12 ohms, okay? So with that, we can find the current. So the current here is going to be V over R. The total voltage is 24 and resistance is 12, so that's going to give us 2 amperes. Now, so the current passing through this is 2 amperes. I hope you are following, okay? So now remember, they are in series. That means the same current here is the same current here and the same current here. So the current here is 2 amperes, 2 amperes, 2 amperes. So the best way to calculate power for each of them, in this case it says for the 4 ohms resistor, is going to be, we can use I squared R since we know the current and we know the resistor or resistance. So that is going to be, the I is 2, so that's going to be 2 squared times the resistor is 4. So 2 squared is 4 and 4 times 4 is 16. So the answer is 16 watts, which is A. I hope that makes sense, right? Now the next question here says 2 resistors of 3 ohms and 6 ohms are connected in parallel across a 12 volt supply. The total power consumed, now this is total, okay, by the combination is, well, since these two are in parallel, we can find the total resistance, and we can use 3 times 6 over 3 plus 6. Remember, when 2 resistors are in parallel, you can simply, to find the total resistance, you can simply multiply, then divide by, you add, you know. That's a way you can do that. If you know, if you can do this, that's fine too. 1 over R equal to 1 over R1 plus 1 over R2, that's fine. But I use this because it helps me get to my answer very fast. Okay, so 3 times 6 is 18. 3 plus 6 is 9. That is 2 ohms. That's the total resistance. So, and we are given the total voltage to be 12. So, to find the total power, since we know the total voltage and the total resistance, we can simply say V squared over R. This works, right? And this is going to be 12 volts all over R is 2. So that is 144 divided by 2. And 144 divided by 2 is 72. So the answer is 72 watts, which is D. Okay, so this is not correct. So this makes a lot of sense, right? And that leads us to number 27. This one has to do with resistivity. It says a wire of length 2 meters and cross-sectional area 0.5 times 10 to the power negative 6 has a resistance of 10 ohms. The resistivity of the material of the wire is, now resistivity has a formula, RA over L. That is the formula for resistivity. Resistance times area over length. Okay, and the resistance based on the question here is 10 ohms. The area, cross-sectional area, is 0.5 times 10 to the power minus 6. Then the length is 2. Okay, it's quite easy. So if you calculate this, 5 times this, 2.5. So A is the answer, 2.5 times 10 to the power minus 6. Very easy, right? Now number 28 says if the length of your wire is doubled and its diameter is also doubled, the resistance of the wire is now here you need to have a very good understanding of direct relations and inverse relations, and I'm going to show you that. Now first off, the resistance of a wire, the relationship between resistance and this is that resistance is equal to resistivity times the length divided by area, if you choose to make resistance the subject of the formula. And if I substitute the value of the formula for area, it is resistivity times length over area is pi d squared over 4. Now what this simply means is that resistance is directly proportional to length, and resistance is inversely proportional to the diameter, the square of the diameter. Note this, proportional to the length, and inversely, sorry, this should be 1 over. So inversely proportional to the square of the diameter. Okay, now this is quite important. Or we can write this as R is inversely proportional to L over D squared. Please note this. Now this is how you go about this. Now when you say two things are directly proportional, it means that if one, what happens to one happens to the other. If one is doubled, the other one will be doubled. If one is tripled, the other will be tripled, right? Now, but if two quantities are inversely proportional, it means that if one is doubled, the other will be halved. If one is tripled, the other one will be divided by 4, and so on and so forth. Okay, so please note this. Now let's see what happens here. The length of the wire is doubled, so that means this is multiplied by 2, it becomes 2L. And the diameter is also doubled, that means this diameter becomes 2D all squared, is doubled too. Because it is because it's raised to power 2, so the square will affect it, so that's going to be 4. So at the end of the day, you are going to have 2 over 4, because 2 squared is 4 and 2 over 4 is 1 over 2, so that means that the resistance is going to be halved. That's how we do that. That's very interesting. You can learn that. So the next one says a cell of EMF 6 volts and internal resistance 1 ohms supplies current to a 5 ohms external resistor. The efficiency of a cell is, now this is important for you to note, the efficiency of a cell is the external resistor all over the sum of the external and the internal resistor multiplied by 100. Okay, so this is equal to, the external is 5 and this is 5 plus the internal is 1, then multiplied by 100. So this is 5 over 6 times 100, which is 500 over 6, which is going to give us 83.33. So the answer is D. Okay, very important. Then comes to the last one. The efficiency of a cell is correctly expressed as, I already gave you the formula in the past one, so this is the answer, R over R plus R times 100%. That is it. Thank you very much. I wish you the best in your exams. Okay.